This week we are doing precipitation and types of clouds. A quick, short week. This information will be useful on your quiz tomorrow. So starting here, the water cycle. I know you guys already know the water cycle. We've gone over it a little bit when we talked about runoff. I'm not going to go over it in detail. This is just one more picture of it. So evaporation, condensation, precipitation. So evaporation, the sun shines, heats up the water, goes into the air. It condenses into clouds. If there's enough, it causes precipitation or rain and snow. And today, as we talk about types of clouds and types of precipitation, we're going to show how the clouds form and why they form in certain places and what weather they bring. So, and then you've got the runoff. First of all, well, let's back up to here. One of the questions, so what is humidity? These are a couple questions from that first worksheet that you're doing. What's humidity? Humidity is, just tell me, yeah, what's humidity?
Water in the air.
Yeah, it's the amount of moisture in the air. We live in a relatively dry climate, so our humidity is generally fairly low and is not, I mean, in the summer it'll be really low. Some of these have, this one doesn't have the humidity on it. Some of them do. But, you know, other places have high humidity, which makes the heat or cold feel more extreme. So then humidity is just measuring how much moisture is in the air. So why do we oftentimes, when you hear the weather, it's described as relative humidity? Now, I know you guys, that was, again, one of the questions on that first sheet. What is relative humidity? Why do they use relative, what is it, and why do they use that instead of absolute humidity? It was question number 4 on your first worksheet. Relative humidity. Yes.
Water vapor that is actually in the air refers to the maximum amount of water vapor in the air can hold at a certain time.
Okay. So it's the percentage of water vapor in the air compared to what it can actually hold. And the reason why you need relative humidity is at different temperatures, the air can hold more water. So what holds more water, warm air or cold air? Warm air. So if the air is warmer, it holds more humidity. And this is important because if the air cools down, what's going to happen to the moisture in the air? It's going to condense. Yeah, and before it freezes, it'll condense. So that's why when it's cool in the morning, you get fog. The coldest time of day usually, before the sun rises, it is actually usually a little bit warmer. And then as the sun comes up, you get this cooling. And as it cools, so then as the sun rises, sometimes you'll get fog or you'll get dew forming on the grass. And that's because as it warms, that's because there's a quick cool down, so the moisture comes out of the air. This idea of relative humidity and the warmer air holds more moisture is also going to be responsible for why we see clouds in certain places, which I'm going to show you here in a minute with how clouds form. All right. Come back to that one. This one is, of course, just a picture from the textbook. But, and this is, you know, kind of our summer pattern, and I'll go back to that kind of Colorado picture in a minute. But warm, moist air rises from the surface, right? Because the ground is warm, heated by the sun, especially in the middle of the day. As it gets up high enough, at a certain height, the air cools to the dew point. Dew point is the temperature where the water will come out of the air. At the dew point, then condensation begins. Water vapor condenses on tiny particles, forming a cloud. And I did this, it's funny, we live in such a dry climate, this didn't work very well. But usually if you have a glass of cold water, what happens to the outside of the glass? Yeah, you get condensation on it. And so if this room was more humid, then you'd have water formed on the edge, right? And that's why when you take a shower or whatever in the morning, the shower is very warm, but the mirror and the surfaces are cooler, so it condenses on those surfaces, making fog or steam or whatever. So that's what happens there. And a similar thing happens. This could happen just during the day, but this is also what happens in Colorado with our weather patterns. I showed you this picture last week, but it makes a little more sense with some of the information that we were looking at today. So you've got cool, wet air, or it might start out as warmer, wet air. And then what's going to happen as that air goes up in altitude? What's going to happen to the water as it goes up in altitude? Is the temperature warmer or colder higher in the troposphere? Colder. And so what's going to happen to the moisture in the clouds? It's going to condense, and then ultimately it's going to fall out as precipitation. And again, we talked about this a little bit last week, but this is the windward side, and so you're going to get more rain, more snow on that side, the side that the wind is coming in on, especially if the air has a lot of moisture coming from the Pacific. Then here, by the time we get on this side, all the stuff has fallen out, and you get this. Now, in the spring, when we get thunderstorms, or sometimes in March when we get warm, or when we get wet snows, those storms are not coming from the west. They're coming up from the Gulf of Mexico. So you get warm, wet air, and it comes up and it goes this way. And so that would be warm, wet air, and that's some of what causes our thunderstorms and warm summer snow. So that's some of how clouds form. Make sure we got all of those. Oh, and this one, do you guys recognize this cloud? Yes. Do you know what it's called? Yes, very good. So it's cumulonimbus, and this is the anvil-shaped cloud. We actually get to see really cool clouds here in Colorado, and particularly here where we live, because of the air hitting the mountains. And so what happens here, you get the warm air and the cold air, and the clouds get very, very tall. And these are going to be thunderstorm clouds. We'll talk about them again in a minute. But as the cloud gets taller and higher up in the atmosphere, there's less pressure, and it spreads out up here. And we get all sorts of crazy things happening that we'll talk about in a minute. Okay, so earlier this week, Monday or Tuesday, you should have filled out something like this about each one of the types of clouds. How many people have this filled out? Okay. So we'll go over it really briefly. I don't want to spend too much time on it, but stratus clouds, and we also have the picture in the textbook. This picture in the textbook has a lot of the information. Does somebody have the page this one's on? 564. Okay. Stratus clouds. Where do we find stratus clouds? What do they look like? They are layered. High, medium, or low altitude? Yeah, low or medium to low. What kind of weather is associated with stratus clouds usually? And the stratus clouds can actually be, when they're really low, they can also cause fog. It can be overcast. Those are stratus clouds, covering usually most of the sky. And then nimbostratus, what does nimbus mean? Rain. So nimbostratus clouds, same thing, only it's actually raining or snowing. And the difference in appearance, these clouds are usually, dark, very dark gray, or sometimes even almost black. Nimbostratus. Cumulus clouds. Which ones are the cumulus clouds? Yeah, the fluffy. Your whole life when you've been drawing cute little clouds, you've been drawing cumulus clouds. It depends on where you live. We get a lot of them around here. What type of, high, medium, or low altitude? Yeah, you can look at the diagram. Good question. Good point. Yeah, cumulus, medium to low. Yeah, medium. Okay. And what type of weather? This is always kind of weird to me. What type of weather do cumulus clouds usually show up in? Sunny weather. Yeah, sunny weather. These are type of clouds for sunny, but they are. So sunny, um, clear. Obviously, it's not going to be totally clear, but generally nice weather. Some of the high pressure or stable weather, you'll see those fluffy cumulus clouds. Okay? Then cumulonimbus, what did we say nimbus meant? Rain or storm. So the cumulonimbus are going to be the rainy cumulus clouds. And some of these, you also get the anvil-shaped, you know, so it's like cumulus, and then it gets really tall and then spread out here and like this and crazy. And these ones go actually from medium to high. They're very, very tall clouds. And we get, what type of weather would we get with our cumulonimbus anvil-shaped clouds? Thunderstorms and hail and sometimes tornadoes and all sorts of awesome summer crazy weather. So hail, thunder, etc. And then finally, cirrus clouds are the wispy clouds like this. Their altitude is high. And what type of weather? Usually windy, sometimes changing weather. And one of the things you were looking at, I don't remember, I know we were looking at it yesterday, but if the cloud is really bright white with kind of sharp edges, what does that mean of what the cloud is made up of? Ice or water? Ice, right? So the cirrus clouds are bright white and they're icy. The nimbus, anything that's nimbus clouds, generally have a lot more water in them, and they've got the darker color to them. So that tells you something both about the altitude and the temperature. And now, okay. All right, so here are a couple beautiful examples. Oh, that's from the textbook. On page, what do you say, 577 or whatever. If you're watching this at home, you can just pause that and write down all that beautiful information. What type of clouds are these? Cirrus, how do you know? They're wispy and feathery and high altitude, and clearly it's windy up there. What types of clouds are these? Cumulus, cumulonimbus. Look at all those. Oh, look, even rain coming down. Cumulonimbus, very good. What type of clouds are these? They're actually cirrus. And the reason I picked these is when we were looking at the textbook yesterday, they were talking about these cirrus clouds that look like fish scales. They're talking about herring sky. Remember when you guys were finding that yesterday? And that just seemed, right, well, mare's hair is like, so a horse's tail. That would be, the horse's tail is these ones, right? But these, you see how that looks kind of like fish scales? Weird, but we do see skies like this. And so I know, creepy, right? But I did that so you could see what those look like. Here's another cloud type for you. What types of clouds are these? Stratus clouds. These are, yeah, stratus or nimbostratus because they're layered, they're very thick, it looks like it's about to rain, it's overcast, it's foggy. Awesome. Next, what type of clouds are these? The cumulus, and not just cumulus, they are the cumulonimbus, and look at this big anvil-shaped cloud. Looks like a mushroom cloud. So these are where you're going to get your thunderstorms. How about these ones? Cumulus clouds, just regular fluffy, very blue sky around it. Now these, have you guys ever seen clouds like this? Yes. These clouds happen only in particular areas due to the winds and the combination of things. It's actually a type of cumulus clouds. They're called lenticular because they're kind of lens-shaped. But we get these around here right over the mountains. When there's the right combination of temperature and wind, they're really cool. They do look like flying saucers. Yes. Okay, then the types of precipitation. Types of precipitation, this is the second section, or the last section. Some of them are really quite self-explanatory. So rain, hail, we'll talk in a minute about how the hail forms. Sleet is where it's kind of rain freezing into snow as it's falling.
When the rain hits a patch of
Right.
Celsius there, and then
Right. So as it's raining, it's turning into ice. Now that's different than freezing rain, because freezing rain is it comes down as rain, but then freezes on the ground. We do not get a lot of freezing rain here, but freezing rain causes what's called ice storms, and it's really dangerous because what happens, actually we got a little of this weekend. The ground is cold, the air is warm, and what happens is instead of having snow covering everything, everything's covered in ice. And it's really pretty, but it's very damaging to power lines and trees. And then there'll just be a sheet of ice on the road that you can't really see. And then fog, snow, sleet. Again, you guys know most of those. This, something you might not think about, the difference between rain and cloud droplets, and even fog is generally some of the bigger droplets. Um, but there's significantly different. So mist, drizzle, and raindrops. So they're all very different sizes, and um, that accounts. I'm not going to ask you that specifically as a question. And then this, because again, this is something that we get a lot of here. In the very tall anvil-shaped cumulonimbus clouds, so you see the big anvil-shaped cloud here. It starts way down here. It goes up to here. And what happens, and I had that cartoon picture in the first one that I can go back to, but what happens is you get updrafts. You get winds blowing up like this. And so the water droplets start forming as rain. They get caught in the updraft. They go up here, and it's really cold. So what happens? They freeze. And then they get a little heavier, and then they come back down, and then they get caught in an updraft, and they freeze a little more. And if you've ever seen the hail pellets, sometimes you can actually see they actually look like this. And you can see the layers of ice frozen over and over and over again.
the snow blown apart, it doesn't get not as
Right, except these, and then finally when they get big enough, they fall down from the sky. And you guys know around here we do get hail. It's usually, pea-sized, but I've seen, pretty good size, like grape-sized hail. That's just downright dangerous if you've ever been out in that. And then it can get baseball or softball sized, much less, um, much less common, but it does happen. And you can imagine when that falls, it's very damaging to roofs and windows and people. So we'll go on to the weather fronts next week. Wanted to go back quickly to this picture. And so then that's just the graphic of what's happening. Questions?